This is the second video for the first set of homework for Math 107. In this problem, you're supposed to compute the grade for a road. The grade is the slope expressed as a percent. So first we have to compute the slope. Some of you may know slope as rise over run. Right? So rise means how high you're going. Actually, here's your road. Say, okay, so you work it like this. This is the rise, and this is the run. The run you have at it to get up to this height from this height. So you subtract the two y's to get the rise. So that's y2 minus y1, and the run will be x2 minus x1. Okay, the road's going from this value up to this value. So how high is it going? Just subtract those two. And then the run, it says it goes, it makes that elevation change in 7,000 feet. And you can be happy here because I used to put some of these in miles and some of these in feet, and you have to change all the units around. So right now you don't have a units problem. Once you work that out, you have the slope. You change that slope into percent, and that's your grade. For this part of the homework, there is a separate lecture on scientific notation, and that's something you need to master. So if you have problems here, go back and review that. What I'm going to explain is what's expected here. Here's an example right here. Let me get the pin. Okay. You're given some value in units. It's not important that you really understand these units, but you can treat them as a word if you aren't familiar with them. Okay. In scientific notation, you have to move the decimal point around to where you can only move it by powers of 3. Okay, 3, 6, 9, minus 3, minus 6, minus 9, like that. Okay, so, and that's explained in the other video. So in this case, I'm going to choose to move it 6 places over. And if I move it 6 places, then it would move over there. So that's 13.5. You've moved it 6, so that's 10 to the 6th. And if you work this out, this million, which is 10 to the 6th, multiplied by 13.5, you will get this number back. This is not an x, that's a sign for times. Now once you've moved that decimal over one of these known units, let's just go and list them. We'll just say 10 to the 9th, 6, 3, and then of course not moving it at all, minus 3, minus 6, minus 9. Okay. This part of the scientific notation can be replaced by a letter. That's a metric abbreviation. Okay, 10 to the 6th that we show here can be replaced by a capital M because that means mega. 10 to the 3rd can be replaced by K because that means kilo, because it's 1,000. 10 to the 9th is billion, okay, G. 10 to the minus 3 is replaced by a little m, meaning micro. 10 to the minus 6 can be replaced by the Greek letter mu, like this, or it can be replaced by MC, if you're using, especially in medicine, they don't use mu, they use MC. And then 10 to the minus 9 is nano, so you can replace it by n. So you see here, this whole business times 10 to the 6 got replaced by m. Let's try on this one that's shown here. So you're starting with grams. This should still say volts. I'm going to move the decimal, and actually I could move it 6 places over. I could have done 3, but I'll do 6. So when I do 6 and I've moved it in this direction, that's 13 times 10 to the minus 6. At this point it's still grams. But this business, the times 10 to the minus 6, can be abbreviated as micro. Let's start with this one. Okay, I have a number here, 938.3 times 10 to the 6th electron volts. Don't worry about electron volts if you don't understand them. Right. Now, if I multiplied this number by a million, by the 10 to the 6th, that would in effect move that decimal point 6 places over. So I would have 938, now 2, 3, 4, 5, 6. You see the decimal point went from here over to here, which was 6 places. On the other hand, I could take the 10 to the 6th and abbreviate it with a capital M. And this is mega electron volts. Now this is a question on piecewise functions, and there is a separate lecture on piecewise functions, and they really aren't that hard. At least I don't think they're that hard, but let's see if we can clarify this. For demonstration purposes right now, I'm going to replace this. Let's say I replace it by 2, and I'll leave the range the same here, or the domain the same. So to draw this, I would have some graph paper. Okay. So here's my graph paper. The next thing you should do is label your axes. In this case, this is y, and this is x. Remember that f of x is another name for y. Then I look over here at this column, and I see the values for x. So I have one little piece here going from minus 30 to minus 20, then minus 20 to 20, and 20 to 30. Remember, in graphing, you can use any scale you want on the x-axis as long as it's linear, and any scale you want on the y-axis as long as it's linear. You don't have to use the same scales, and every time there's a tick mark, it doesn't mean 1. It can mean 10. So it looks like I'm going from minus 30 to 30, so I'm going to mark off my graph here. So I'll call that minus 10, minus 20, and here's minus 30. And over here, 10, 20, 30. Obviously not a very good job, but that's how it is. Alright. Now the values in x are going from minus 5 to 5, so it looks like I can mark the y-axis off in ones. Let's say that's minus 5, and then I have the same scale up here. So now that I have the graph paper set up, I go back and look. What this piecewise function means is that the function has the value of negative 5 as long as x is between minus 30 and minus 20, although you can see this, it's less than sign. This is a less than or equal to sign for the minus 30. That means it's going to have the value here. Here's my minus 20 right here, and between those two values, the function is staying at minus 5. All right. Okay, because it's less than or equal to here on the minus 30, I can fill that in with a solid circle. This is going to be an open circle right here. Fine. Now I look up here, and I replace this line for right now, just to give a demonstration. Let's say the function has a value 2 when x goes between minus 20 and 20. So these are the values of x at which the function has a value 2. Alright, so here's 2 here. Here's minus 20. It's a solid circle. I can fill that in. And here's my 20 over here, so I put an open circle. And now between 20 and 30, the function has a value 5. Well, the 20 is included, so I put a solid circle here, go out here, and another solid circle. Right? So that's the first thing to understand in piecewise functions, is that here is like a little function by itself, but it's only graphed between minus 30 to minus 20. Here it has a value of 2, but only between minus 20 and 20. Here it has a value of 5, but only between 20 and 30. Okay, that was for constants. Now I'm going to erase this and do it for that for the one that's the problem there. So now I'm going to go ahead and draw myself some graph paper. Okay. Here's my x, here's my y again. And I've got a minus 30, minus 20, minus 10, 10, 20, 30. All right. The pieces on the edge are the same as before, so you know what those are like. Oh, I didn't mark the y. 2, 3, 4, minus 5, and okay. So I know that between minus 30, let's put that in a different color, minus 30 and minus 20, it has a value of negative 5. This point is included, this point is not. Now between 20 and 30 it has a value of positive 5. So it goes through here. Both endpoints are included, so I show them with a solid circle. Now what do you do in the middle? Okay, this is the trick. The function looks like this. Well, x over 4 is what that is, 0.25x, when x goes from minus 20 to 20. That happens to be a straight line, but the trick is no matter what you have, always evaluate that function at the endpoints. So this is really 0.25x is x over 4. So first I evaluate it at the minus 20. So I've got minus 20 over 4. That gives me negative 5. That means when x is negative 20, the function in the middle has a value of minus 5. Okay, and that point is included, so I can put that down. By the way, the solid dot goes over an open dot and covers it up. Okay, now evaluate it at the other end point, which is 20. So 20 over 4 is 5, and so when x is 20, it has a value of 5. Right, and it's not included, so I put an open circle, but that works out. Okay, since this is a line, that's all you have to do, and you connect those 2 points, and there is your piecewise function.